Quick video on a 2015 JKU, not a Rubicon, but it's got all the options. Probably one of my favorite combinations still, just the sound and the way it shifts and delivers the power. This Jeep has the Motch module in it, not the mocan module, and we're going to talk a little more about the differences in another video. The Motch module is pretty amazing. It incorporates our CAN technology, but also has other functions that make it a step above mocan and other CAN interfaces. So what's different about the Motch module and the mocan module? Well, you all know that the mocan module interfaces your JK through the CAN network, and it works very well. The Motch module for many years has been developed as a universal interface, and there's some advantages running the Motch module over the mocan module in several situations. One, if your vehicle does not have a CAN network, obviously you're not going to be doing CAN to CAN. Two, if you're doing something different, you're doing a Mazda, you're doing a Porsche, the Motch module can take signals in, cruise control signals, coolant temp signals, RPM signals, convert them and put them back out in an analog fashion, where the CAN module cannot do that. The CAN module is pretty much slave to the two networks or three networks that you're working with. It's pretty bespoke, which means you can't just take the CAN module out of a Chrysler Jeep and then put it into a Mazda and expect it to work. All the coding would have to be reworked, where with the Motch module, that's not necessarily true. We can use virtually the same module for almost every vehicle. The way we integrate into the CAN has become important. The way we've decided to integrate our CAN is the least invasive as possible. Your vehicle has several CAN networks, including high-speed priority CAN networks, and we've decided to stay out of those. The problem with tying into those networks is there's so much information being transmitted. Once you get onto that bus and begin corrupting it, a lot of bad things can happen, a lot of good things can happen, and you can get higher level priority messages on some of these higher level networks, but at the same time you can do more damage. So what we've done is we've come up with a way tapping into the CAN network in a low priority situation. In this way we have the least amount of effect on the CAN network, we have the least chance of failure or CAN corruption, yet we still get all the functionality that we want. Now I will say that the Motch module is key to that. We're not modifying any modules in the system. We're not modifying the TIPM, we're not modifying the PCM, we're not modifying the instrument cluster, we're not modifying the shift lever position sensor module. If you start tapping into high priority network, there is a chance that you can have some issues with CAN corruption. The CAN is a pretty robust network and it will usually repair itself, but you might see things like when the battery is disconnected and you power back up, the prindle on your dash may not show up, or you may have to reset the battery in order for everything to come back again. And that's not only true in these engine conversions, but that's true even in a stock vehicle. If something goes wonky, like your windshield wipers are gone unintentionally, or your headlights are on, or even a door lock doesn't work and you disconnect the battery and hook it back up, it might just work again. So what we've decided to do is go into the direction of the least invasive way possible. Now along with that goes functionalities, and this is kind of difficult to explain, but let's take for example RPM. You think of RPM as just such a simple signal going into the vehicle, and it's really not. What happens is you have a crankshaft position sensor that feeds a signal into the powertrain control module in the earlier JKs and the engine control module in the later JKs. That signal is a hardwired signal that is decoded by the PCM, then transmitted onto the CAN network. Once it's on the CAN network, it travels through to all the other modules, your ABS module, your TIPM, instrument cluster, and whatever else needs engine RPM to function. Well, we can just put an RPM signal onto the network off the GM side, but that's going to set up some issues, and I'll try to explain. When A signal is hard-coded into a module, and let me just pause here and say that many signals are hard-coded into a module for safety reasons. Signals like brakes, neutral safety, RPM are hard-coded into a module because they're proprietary and they're related to safety. So while you can get some of these signals over the CAN without a wire, the manufacturers are required to do it with a wire, because your park neutral safety, for example, it's much more safe to have a hard signal going to a switch than it is to depend on electronics. You probably never have an issue with electronics, but that's just how the DOT and manufacturers have set this up. So we can send a signal, whether it's coolant temp or RPM, into the CAN network. The instrument cluster is going to pick that up and it's going to display it. The TIPM is going to use it for fan control and other functions, and other modules, including the ABS module, will also pick it up. And many functions are based on RPM. Air conditioning, cooling fans, charging system are all based on seeing valid RPM signal. Now, we're not just talking about a valid RPM signal, we're also talking about a valid camshaft position sensor signal. This gets a little bit technical, but all the way back into the days of the Iacocca K cars, when they went to the 4-cylinder, Chrysler basically killed off the land-going dinosaurs with the 440s and the 360s. Those really were the days. But they went to the little 4-cylinder, put a belt drive, and the motors were interference engines. What that means is when the valve went down and the piston came up, if the timing chain went out of phase, the valve could smack the piston. So they call them interference motors. Some engines, most engines at the time, were non-interference engines. So if the timing belt broke, there's a chance you were going to smack a valve on a piston and break something. So Chrysler did what they call their camshaft crankshaft synchronization. And it was a little frustrating in the early days, because if the camshaft went out a tooth, or even two, the engine was still running, which means you could have drove it to a dealership with a check engine light on, but instead they chose to shut the motor down. So this cam crank sync has carried through the years on Chrysler, right up into your JK. So we have to have a camshaft position sensor signal also. Not only do we have to have a camshaft position sensor signal, but it has to be synchronized. These trigger wheels on your camshaft and on your crankshaft have missing teeth and solid teeth. And by doing that, they can identify top dead center. With the camshaft and the crankshaft synchronized, the computer can determine engine position or crankshaft position to within just a couple of degrees of the 360-degree rotation or the 720-degree combustion cycle. So they can get much more accurate fuel and spark and other control over the engine, as well as misfire detection, by having this. So we need to put in this camshaft and this crankshaft signal. Can you run it without the camshaft signal? Yes, of course you can. You'll have a tachometer. There are issues associated with that. One-touch start, remote start, even your instrument cluster operation. You'll notice that if you don't have a camshaft signal, it'll take about 5 seconds to get a valid RPM signal. But yes, you can do it. And over the years, we've played with several different configurations on how to do this. And really the best way to do this is for the PCM to have the information it needs, period. What that means is hardwiring a RPM and a camshaft position sensor signal into the PCM. Once you do that, you set up a whole series of events. When you hit the key, as soon as that engine starts rotating over, the crankshaft and camshaft position sensors are going to sense that the engine is turning. They're going to know exactly how fast it's turning. Once it starts, the PCM will use its logic to know that it has started and shut off the starter. If you don't have that logic, your starter might run on, might grind. It uses the camshaft position sensor essentially to turn off the starter motor. So if you don't have your camshaft position sensor hooked up, you could have some issues there. Manual transmission vehicles don't have that functionality, so you don't really have to worry about the anti-grind or the remote start function part of this, but the automatic JKs do. So what else happens with these signals? Well, the PCM takes this signal and uses the hardwired signal into the PCM for all of its functions. That's to control spark, to control fuel. These are ultra-fast signals that need to be controlled properly. And by using this hardwired signal rather than a CAN bus signal means it's going to be instant and real time. Now, the tachometer doesn't need such precision. The tachometer gets a CAN bus signal from the PCM. The PCM takes this hardwired signal and it puts it onto the CAN bus. The CAN bus then carries this signal through all the modules that need it, as we discussed, and then each module reacts accordingly.